Let us now see how to set up the sliding mesh problem. First, we enable the appropriate option for modeling transient flows in the general settings. So we go to general settings, we click on edit, which takes us to the general settings panel. Here we select either the pressure based or density based solver, velocity formulation, and the transient solver, which can be steady or transient. In most of the cases, in case of sliding mesh, it is going to be transient and absolute formulation. Then we set the cell zone conditions for the sliding mesh. Then we set the cell zone conditions. For this, we go to cell zone conditions, click on any of the cell zones and click on edit. In the cell zone box of each moving fluid or solid zone, we enable the mesh motion option, which is this. Instead of the frame motion option, we enable the mesh motion option. And here we set the translational or rotational velocities for modeling sliding mesh. The speed can be constant or a transient profile. Next, we go to boundary conditions. We select most of the boundaries, whether they are inlet, walls, and we set up the appropriate boundary conditions. Here we have to set the boundary condition for the sliding motion as well. We change the zone type of the interface zone of adjacent cell zones or interface in the boundary conditions. By default, the velocity of the wall is set to 0 relative to the motion of the adjacent mesh. So if we select a wall, we have to set the velocity as 0 with respect to the adjacent mesh, so that it is actually moving with the adjacent mesh or rotating. For walls bounding a moving mesh, this results in a no slip in the reference frame of the mesh. Hence, we do not modify the wall velocity unless the wall is stationary in the absolute frame. Now we need to define the mesh interface.